Good morning everyone. So students, in the previous class we discussed about the magnetic field on a current carrying conductor. Yes. So current carrying conductor ನಲ್ಲಿ magnetic field ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು discussion ಮಾಡಿದ್ವಿ. Yes. So today we will move towards the next point, that is motion of a charged particle in a magnetic field. ಅಂದ್ರೆ ಏನು motion of a charged particle. So ಒಂದು charged particle ಅದರ motion magnetic field ಅಲ್ಲಿ ಇದ್ದಾಗ ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವೀಗ discussion ಮಾಡ್ತೀವಿ. Yes. So students, here this is the important for your exam purpose. Maybe 5 marks or else 3 marks. Yes. So it is important for your exam purpose. Then see, first in order to start this one we have to consider the one diagram here. Yes. So in ಮಾಡಿ ಒಂದು plain sheet ಅನ್ನು consider ಮಾಡ್ತೀವಿ. Yes. So now what you take here just assume one charged particle is there. Yes. So here one charged particle is present. So ಇಲ್ಲಿ ಒಂದು charged particle ಇದೆ. So now it is moving means of course it has a velocity. Yes. So movement ಅಂದ್ರೆ ಏನ್ರಿ velocity. Yes. So you know that from the right hand rule. So right hand rule ಏನು ಹೇಳುತ್ತೆ ರೀ, the magnetic field it will inverse. Yes. Magnetic field inward move ಆಗುತ್ತೆ ರೀ inside the board. Yes. Then velocity ಇದು ಈ side move ಆಗುತ್ತಾ. Yes. Then force ಹೇಗೆ ಅಪ್ಲೈ ಆಗುತ್ತೆ ರೀ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ perpendicular direction. Yes. So ಈಗ ಈ ಪಾರ್ಟಿಕಲ್ ಇದ್ದು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಫೋರ್ಸ್ ಹೇಗೆ ಅಪ್ಲೈ ಆಗುತ್ತೆ ರೀ perpendicular direction ಅಲ್ಲಿ. Yes. So what you do, just you take the force here. So force will apply like this. Yes. So ಈಗ ಪಾರ್ಟಿಕಲ್ ಹೀಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ and I will apply the force like this. So what it will do, ಇದು ಹೀಗೆ ಹೋಗೋ ಬದಲಿ ಸಡನ್ಲಿ ಹೀಗೆ ಹೋಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Yes. Direction change ಆಗುತ್ತಾ, ಹೀಗೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ, but when I apply the force on this it will changes the direction like this. Change ಆಯ್ತಾ direction. So now it will start to move in this direction. Yes. Again the force will apply. Yes. Again the force will apply on this particle. So what happened? Again it changes the direction. Yes. Again it changes the direction. Then again force will apply. So again it changes the direction. Yes. So next ಮತ್ತೆ force apply ಆಗುತ್ತಾ ಇಲ್ಲಿ ಈ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ. So ಮತ್ತೆ ಏನಾಗುತ್ತೆ, again it will change its position. Yes. So again here also force will apply, right? Then again it start to changes its position. Yes. So now again the force will perpendicular, then again it will changes the direction and comes here. Yes. So now you can see it passes the, it shows the circle to you. Yes. So ಏನಾಯ್ತು ಈಗ ಇಲ್ಲಿ ಫಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಇತ್ತು, ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಗೋದ್ರಿಂದ ಇಟ್ ಚೇಂಜಸ್ ಇಟ್ಸ್ ಡೈರೆಕ್ಷನ್, ಮತ್ತೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಯಿತು, ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಯಿತು. ಸೊ ಇದೇನಾಯ್ತು ಈಗ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅನ್ನು ಕವರ್ ಮಾಡಿದೆ. Yes. But you can see now the forces are towards the center. Yes or no? So force ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇವೆ ರೀ, towards the center. Yes. So see center means we can take it as a radius. Yes. So ಏನಾಯ್ತು ಈ ಫೋರ್ಸ್ ಎಲ್ಲ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇವೆ, towards the radius. Yes. ಅದಕ್ಕಾಗಿ ನಾವು ಈ ಫೋರ್ಸ್ ಅನ್ನು ಏನಂತ ಹೇಳ್ತೀವಿ, ರೇಡಿಯಲ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. What we will say, radial force. Yes. Or else the forces towards the center, that forces we can call it as centripetal force. What we will say, centripetal force, right? So exactly direction at the center. That's why we call it as centripetal force. Understood? So this only I can written it as if a charged particle enter a magnetic field. Yes. So ಇಲ್ಲಿ charged particle move ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ of course there is a presence of the magnetic field. Yes. So there is a presence of the magnetic field. When charged particle enters the magnetic field, right angle to it. Right angle ಅಂದ್ರೆ ಏನ್ರಿ? Perpendicular direction. Yes. Then it moves in a circular path due to the magnetic force. ಅದೇನಾಗುತ್ತೆ? Circular path ನಲ್ಲಿ movement ಆಗೋಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. Why? Because of the magnetic force. F is there, no? Magnetic force. Then which act as a centripetal force. ಅದು ಹೇಗೆ ಆಕ್ಟ್ ಆಗುತ್ತೆ ರೀ? Centripetal force ನ. Yes. Now I will draw it again. Just take here. So this is the center, and here just assume charge is present, and this is the take it as a radius. Yes. Then here the charge is moving with having the velocity v, and then here the magnetic field is present. Yes. So you can take the charge here. It is at the center, and here charge is present. So it is moving in this direction with the velocity v, but the force will apply F. Yes, that is a magnetic force. Due to this, the particle will start to move in a circular path. That forms the centripetal force. ಇದನ್ನ ನೀವು already ಈಗ ಕಲಿತಿದ್ದೀರಾ. Yes. So now what you do? See here. Of course, here magnetic field will also present. Yes. Here just consider. Here there is a presence of the magnetic field. Charge move ಆಗ್ತಾ ಇದ್ರೆ ಅಲ್ಲಿ magnetic field produce ಆಗುತ್ತೆ ಅನ್ನೋದು ನಿಮಗೆ already ಈಗ ಗೊತ್ತಿದೆ. Yes. So ಈಗ ಏನಾಯ್ತು? Now we can write the force. Yes. Force in the magnetic field we can write. Yes. See, before that, first you have to write the centripetal force. So centripetal force ಎಷ್ಟಿದೆ ರೀ? What is the value of the centripetal force? See, F here magnetic FB. B means what? Magnetic field. Force in the magnetic field. That is nothing but the centripetal force. How much it is? mv square by r. Yes, this is standard equation idea. It is a centripetal force. What is that? Force in the magnetic field, that is nothing but the Lorentz force. Yes, is equal to the mv square by r, where m is the mass of the charged particle. Yes. Then v will be the velocity of particle, charged particle. R will be the radius of circular. ಈ circular path ದು radius ಅನ್ನು ನಾವು ಎಲ್ಲಿ ತಗೊಂಡಿದ್ದೀವಿ? R. Yes. So you already know about this Lorentz force in the magnetic field. What is the value of that? We know that. So FB is equal to QB. Then what is that? Lorentz force value is how much? That is QVB. Yes. So Lorentz force value is QVB. What is QVB? Charge, magnetic field, and the velocity. Yes. So put this value here. So FB is how much now? QVB. So QVB is equal to mv square by r. So now you can cancel the v and v. V is equal to QB R divided by M. Yes, this is the first equation. Yes, so take it as equation number 1. So here what we calculated? Velocity. Illa we calculate madidvi velocity. So velocity is nothing but the charged particle into magnetic field into that radius divided by mass of the particle. Yes, so ಈಗ q ಮತ್ತು r ಅನ್ನ ಕಾನ್ಸ್ಟಂಟ್ ಇಟ್ಟಾಗ ಏನಾಗುತ್ತೆ ರೀ? v ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹೇಗೆ? b ಜಾಸ್ತಿ ಆದಾಗ. Yes or no? So here the charge particle radius and the mass we have to keep constant. The constant idಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ? Velocity increase ಆದ ಹಾಗೆ the magnetic field will also increases. Yes. So ಈ equation ಇಂದ ನಾವು again we have to write the radius. So what we will get the radius? See, r is equal to v m divided by qb. Yes, this is the radius of the circular path. Yes, so this is the radius of the circular path. What is velocity mass divided by charge into that magnetic field. So what will happen now? See, radius ಜಾಸ್ತಿ ಆದ ಹಾಗೆ magnetic field ಜಾಸ್ತಿ ಆಗುತ್ತಾ? No. Why? Because they both are inversely proportional. Yes, so they both are inversely proportional to each other. Yes, see now we have to calculate the time period. Yes, so now time period anna calculate ಮಾಡಬೇಕು. Time period of a circular path. What we have to calculate? Time period of circular path. So in order to calculate the time period of circular path, what will happen? The linear velocity will be equal to the angular velocity. Yes, angular velocity of this centripetal force. Yes, so your time period anna calculate ಮಾಡಬೇಕಾದ್ರೆ linear velocity ಅಂದ್ರೆ ಯಾವ್ದು? Linear velocity v is equal to angular velocity, that is how much? R into W or else omega. Yes, this is linear velocity is equal to R into omega is nothing but the what it is? Angular velocity at the center. Yes, this omega is nothing but the angular velocity. So you already know the value of v. Yes, so put the value. V is how much? QBR divided by M. Yes, so put the QBR divided by M is equal to R omega. Right, so R get cancelled. What remains? Omega is equal to QB by M. This much remains. This is the angular frequency. What it is? Velocity. So now I will calculate the time period. This time period, how we calculate? See, what is the equation for the time period? See, time period. See, omega is equal to 2 pi by t. Right? This is the time period equation. So put the value of this omega now. How much we will get? QB by M 2 pi divided by t. So what we will get? T is equal to QB by M. This will also comes this side. Yes. So what will happen? It will go. 1 minute. Just we will adjust it. QBT 2 pi M. So now T is equal to 2 pi M divided by QB. Yes, this is the time period equation now. See, this much time it will take. Charged particle will take this much time to cover the circular path. Yes. So here see, when the angular velocity will increases, when the magnetic field will increases. Yes. But in Q ಮತ್ತು M ಅನ್ನು ನಾವು ಏನು ತಗೋಬೇಕು? Constant ಇರಬೇಕು. Yes. When we take the Q and M constant, that time this omega means angular velocity will increases with the magnetic field. Yes. So after this, see time period calculate ಮಾಡಿದೀವಿ ಅಂದ್ರೆ we can calculate the frequency also. Yes. So frequency ಅಂದ್ರೆ ಏನ್ರಿ? 1 second ನಲ್ಲಿ ಎಷ್ಟು rotation ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Yes. Maybe you know that F is equal to 1 by T. Yes. Frequency ಅಂದ್ರೆ ಏನ್ರಿ? Frequency in 1 second how many rotations it will cover, that we can call it as frequency. So ಈಗ 1 second ನಲ್ಲಿ ಎಷ್ಟು rotation ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. So frequency is equal to 2 by mu. Yes. So here F is nothing but the frequency. Yes. F is the frequency. So F is equal to 2 pi mu. Yes. So now what will happen? 2 pi mu is equal to what we will get? QB by M. Why? Just see omega. Yes. Here omega is nothing but the angular velocity. Yes. That only I consider here. 2 pi mu is equal to QB by M. Then what will happen? See, now I have to consider this, that is the frequency. So mu is equal to QB by 2 pi M. Yes, this is our frequency. Yes, frequency equation. See, you can always you know that F is equal to 1 by T. Right? See here, 1 by T. Frequency ಎಷ್ಟು ಬಂದಿದೆ? QB by 2 pi m. Yes. Time period ಎಷ್ಟು ಬಂದಿದೆ? 2 pi m divided by QB. ಎರಡು ಅಪೋಸಿಟ್ ಇದೆಯಾ? Yes. ಯಾಕಂದ್ರೆ ಇದು frequency mu ಅಂತ ಕರೀತೀವಿ. Yes. ಅದನ್ನೇ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ? mu ವ್ಯಾಲ್ಯೂ QB by m. ಅದನ್ನೇ ಇಲ್ಲಿ ಪುಟ್ ಮಾಡಿದ್ದೀವಿ. Yes. Then see this frequency ಮತ್ತೆ time period ಯಾವತ್ತು inversely proportional ಇರುತ್ತೆ. Inversely ಅಂದ್ರೆ ಏನ್ರಿ? Opposite ಇರ್ತದ. Yes. See you can QB ಇಲ್ಲಿ ಮೇಲಿದೆ, ಇಲ್ಲಿ ಕೆಳಗಿದೆ. ಇಲ್ಲಿ 2 pi m ಕೆಳಗಿದೆ, ಇಲ್ಲಿ 2 pi m ಮೇಲಿದೆ. Understood? So they are opposite. You have to keep it in your mind. Then after this we have to calculate the kinetic energy. Yes, kinetic energy. Now we have to calculate the kinetic energy. See, kinetic energy formula, how much it is? Kinetic energy is the half mv square, right? Half m. What is the value of v? Here we calculated qbr by m, right? So qbr by m whole square. So what we will get? Half m q square b square r square divided by m square. So m will get cancelled. What remains? Q square b square r square divided by 2m. So this is the kinetic energy. Now this is also the one important equation, right? So first we took the centripetal force. Centripetal force to only formula entry FB. FB and the Lorentz force in the magnetic field. Yes, other value is to QBV. Yes, avale mv square by r aita centripetal force to. Yes, so Lorentz force value is 3 QBV. Put the value here is equal to mv square by r. Yes, so BV get cancelled. So velocity is 3, QBR divided by M ಬರುತ್ತೆ. Right? So after this, ಈಗ ನಾ radius ಅನ್ನು calculate ಮಾಡ್ತೀವಿ. Yes? See, from one equation we can calculate the number of equations. ಅಂದ್ರೆ one relation ಇಂದ ನಾವು ತುಂಬಾ relations ಗಳನ್ನ find out ಮಾಡಬಹುದು. So now R is nothing but the VM divided by QB. That only I written there. ಆಮೇಲೆ ಏನು ಮಾಡ್ತೀವಿ, time period ಅನ್ನು calculate ಮಾಡ್ತೀವಿ. Yes. So just consider here what is the time period it will take to cover the circular path. Yes. So ಅವಾಗ ಏನಾಗ್ತದೆ, linear velocity is equal to the angular velocity at the center. So linear velocity ಯಾವ್ದ್ರಿ, is equal to r into omega. So omega ಅನ್ನೋದು ಮೇಲೆ angular velocity ಆಗಿದೆ. Yes. So v value ಏನು, from this just you put here and then r omega. So r will get cancel and you will get the angular velocity as how much, qb by m. Correct? Then time period we have to calculate now. T, time period. Yes. So that is omega is equal to 2 pi by t. Right? So omega value is 3, qb by m the value 2 pi by t. Now we have to calculate the time period. Yes. Adjust ಮಾಡಿ, time period is equal to 2 pi m by qb. So time period calculate ಮಾಡಿದೀವಿ ಅಂದ್ರೆ frequency calculate ಮಾಡಬೇಕು. That is mu is f is equal to 2 pi mu. ಅಂದ್ರೆ frequency ಇದು ಇದಕ್ಕೆ equal ಇರುತ್ತೆ ರೀ 2 pi mu. Here you just take frequency as a omega. You will not get a confusion. Yes, frequency omega is equal to 2 pi mu ಅಂತ ಆಗುತ್ತೆ. Right? So 2 pi mu is equal to ಇದೆಷ್ಟಿದೆ frequency value ಅಥವಾ velocity, angular velocity or angular frequency. That is qb by m. So calculate this mu, angular frequency, qb by 2 pi m. So time period ಮತ್ತು frequency ಯಾವಾಗಲೂ inversely proportional ಇರುತ್ತಾ. From this, so take it here. Then after this, calculate the kinetic energy. Right? So kinetic energy is equal to half mv square. So put the value of v. V ಎಷ್ಟು ಬಂದಿದೆ ರೀ, qbr by m. So square ಮಾಡಿ and you will get the cancel there m and you will get last kinetic energy is equal to q square v square r square by m. Understood? So this is the one important derivation that given for your syllabus. Yes. See, ಇನ್ನೊಂದು ಬರ್ತಾ ಹೇಳೋಕೆ, ಈಗ ನಾವು ಇಷ್ಟು ಸರ್ಕಲ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ. ಎಸ್. ಸೊ ರೇಡಿಯಸ್ ಇಷ್ಟಿದೆಯಾ? ಎಸ್. ಸೊ ಈಗ ಏನಾಯ್ತ್ರಿ, ರೇಡಿಯಸ್ ಜಾಸ್ತಿ ಆದ ಹಾಗೆ ಇದು ಜಾಸ್ತಿ ಆಗುತ್ತಾ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತಾ? ನೋ. ಅಥವಾ ಟೈಮ್ ಪೀರಿಯಡ್ ಜಾಸ್ತಿ ತಗೊಳುತ್ತಾ ಇದು ಮೂವ್ಮೆಂಟ್ ಆಗೋಕೆ? ಡೆಫಿನೆಟ್ಲಿ ನೋ. ಸಿ ರೇಡಿಯಸ್ ವಿಲ್ ವಾಟ್ ಎವರ್ ಇಟ್ ಚೇಂಜ್. ಸಿ ಸರ್ಕಲ್ ಈಗ ಸ್ಮಾಲರ್ ಇರ್ಬೋದು ಅಥವಾ ಲಾರ್ಜರ್ ಇರ್ಬೋದು, ಬಟ್ ಟೈಮ್ ಪೀರಿಯಡ್ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಸೇಮ್. ಎಸ್. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ರೀ, r is equal to vm by qb. ರೈಟ್? ಸಿ ವೆಲಾಸಿಟಿ ಅಂದ್ರೆ ಏನ್ರಿ, ರೇಡಿಯಸ್ ಬರುತ್ತಾ? ಎಸ್. ಸೊ ಸರ್ಕಲ್ ಬಿಗರ್ ಇರಲಿ ಅಥವಾ ಸ್ಮಾಲರ್ ಇರಲಿ, ಎಸ್, ಟೈಮ್ ಪೀರಿಯಡ್ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಸೇಮ್. ದೇರ್ ಇಸ್ ನೋ ಡಿಫರೆನ್ಸ್ ಇನ್ ದಟ್. ಮೂವ್ಮೆಂಟ್ ಆಗೋಕೆ ಅದು ಟೈಮ್ ಪೀರಿಯಡ್ ಅನ್ನ ಸೇಮ್ ತಗೊಳುತ್ತೆ. ಹೌ ಮಚ್? 2 pi m divided by qb. Understood? So this is about the one important derivation, that is motion of a particle in a magnetic field. Understood?